Hello there, this is going to be the first recording for Pre-Calculus 2. I currently have the Chapter 2 PowerPoints up. We're on slide 5. This is the double angle formulas, and this can be found in your book on page 243. So these are different ways of being able to rewrite something that has a multiple of it. So instead of sine of x or sine of theta or sine of something that we are used to, if you have sine of 2 of something, you can rewrite that as 2 times sine of that something times cosine of that something. And if u happens to be something other than just a variable, you can break it up into other pieces, which I'll show you in one of the problems that I'm about to do. All right, so there's one for the sine of 2u, there's one for tangent, and there's one for cosine. Actually, there's 3 different versions, but a couple of these involve the other identities, the Pythagorean identities for the cosine. But right now we're going to focus on this first one. So sine of 2u equals 2 times sine of u cosine of u. So I've got here 2 different problems from your book. So this is again chapter 2.5. The page of your homework is on page 250, and I've added the general caveat that I've done in class. We're going to solve the equation for just 0 to 2 pi, not every possible value that we can find for this. Just 4 values of x between 0 and 2 pi, including 0 but not including 2 pi. Okay, so we have our first double angle one there on the left. So we have this sine of 2x here. So what we're going to do is we're going to rewrite this using that first formula so that we can then get something that's a product of just sine of x and cosine of x and go from there. And this will be a general trick for this. So let's see if I can do this. All right, so sine of 2x can be rewritten as 2 sine of x cosine of x. So that's what our first bit can be written as here. This guy here can be written as 2 sine of x times cosine of x. So we bring down the rest of it. And now we're in a situation where we're trying to solve for something, solve for x, in this case for the given functions of x. And we have a sum of things, or a difference in this case of things on the left. In order to be able to solve these, we have to have a product of any number of things equaling 0. That way, if any one of them equals 0, the entire thing equals 0. So we can factor a sine of x out from each piece of this. So I'll write sine of x times the quantity 2 cosine of x and minus 1. I'm taking the sine of x out of here. There's still something there. It's just 1. And that all equals 0. So now if either the first part here, sine of x, equals 0, or if this part here, 2 cosine of x minus 1 equals 0, our entire equation will be equal to 0. So let's deal with the first part here. So sine of x equals 0. So when does that happen in 0 to 2 pi? Well, the only times it's going to equal 0 is at 0, pi, 2 pi, 3 pi, and so forth. Well, we don't need the 2 pi, so this means that x has to either equal 0 or pi, and both of them will work. And then for the other part here, I'm going to rewrite this as 2 cosine of x equals 1. because if this part equals, if the whole thing equals 0, if I add 1 to each side, I get this. I can then divide by 2. And now we have to figure out where cosine of x is going to equal 1/2. And we can look at our unit circle, remember the progression of what we're doing as far as going up from the 30, 60, and so forth. So this is the smaller version. So this is going to happen up near pi by 2. So this is going to be at our 60-degree mark, which is pi by 3. So here, x is going to equal pi by 3. That's going to work. Notice that our cosine is positive. So the other value that's going to work here is going to be in quadrant 4. That's going to be essentially negative pi by 3, which if we go all the way around, find something coterminal to that, we're going to look at 7 pi by 3. No, that's too much. 5 pi by 3. Just erase that. So these are all of our possible solutions. You can just write them like this. There's no problem with that. All right, so this one would be solved. And now we have another problem over here, and hopefully I have enough room for this. We'll see. All right, so now we have a sine of 4 times something, and then another sine of 2 times something. But we know that 2 times 2 equals 4, so I can simply write sine of 4x as sine of 2 times 2x. I'm sorry, that this equals this. So this equals a negative 2 sine of 2x, so it equals that. Okay, so now I have 2 times a u. In this case, my u would be 2x. So I can still use the double angle formula to write this as 2 times sine of 2x cosine of 2x. Don't forget this cosine of 2x. If you just write x, it's going to be a problem. And this equals negative 2 sine of 2x. And now I'm in a similar situation to where I was in the first problem. So if I add the right-hand side, or add 2 sine of 2x to each side, I get 2 sine 2x cosine of 2x plus 2 sine of 2x, and that equals 0. So again, very similar to the other problem, I have, in this case, a sum of two things, which I need to make a product. I have a commonality of the sine of 2x here. So I'm going to just factor out that. In fact, I'm going to factor out 2 sine of 2x because that won't matter in what we're doing here. So we'll factor out 2 sine of 2x. And so that's going to leave me with cosine of 2x plus 1. And all of that equals 0. So now I'm good if either this piece equals 0 or this piece equals 0. Well, let's take a look at the first one. So if we have 2 sine of 2x equaling 0, that means sine of 2x equals 0. But if we know that sine of 0 will be 0, sine of pi will be 0, sine of 2 pi will be 0, and so forth. So essentially, 2x has to equal 0, pi, 2 pi, and so forth. But our answers for x have to be between 0 and 2 pi. So in our first one, we would have x equals 0 over 2, which means x equals 0. In our second version, we would have x equaling pi by 2. And our third one here, we would have x equaling 2 pi over 2, which means x equals pi. And then we're going to be done. If we go to 3 pi, no, we've got one more. We can go with 3 pi, excuse me. So let me just scroll this down a little bit. So if we have 2x equaling 3 pi, that gives us x equals 3 pi by 2, which is still less than 2 pi. The next one, if we use 4 pi, 2x equals 4 pi means x equals 2 pi, but we're not going to use that because that's outside of our range or domain, excuse me. So our different possible values here are going to be x equals 0, pi by 2, pi, and 3 pi by 2. All right, so now we have to check cosine of 2x plus 1 equals 0. So that means we have cosine of 2x is going to equal negative 1. All right, so where does cosine of 2x equal negative 1 in the general 0 to 2 pi situation? Well, that's going to happen at pi, and then again at 3 pi, and again at 5 pi, and so forth. So we have 2x having to equal pi, which means x equals pi by 2. And another possibility is 2x equals 3 pi, which means x equals 3 pi by 2. If I had 5 pi, that 5 pi by 2 is going to be outside my scope, so I'm done here. But please notice that both of these are already answers that we have over here. So our complete list will be in the box there. And these are the first two problems I have to you, and they're both in the same section, and I will use another one of those double angle formulas for you in the next video.